is that we have made no, you will do the exercises of these two and then start with the causal loop modeling today. Okay. The purpose of this particular lecture of what we are going to do for the next 2.5 days. And this is a model that we use in various parts of the world to deal with complexity. And it's more a process, so I want to show you where the different things you're going to do, where it fits in to each other. It takes the systems thinking concepts and tools to where it can be used by anyone. Doesn't matter whether you are a marriage counselor, whether you're a biotechnologist, whether you're an engineer, or whether you're a businessman. And the nature of the systems tools I'm going to talk about is tools that through years of experience that we have done, we have used these, we've defined that these are the best tools for everyone. This is not tools that you would particularly prescribe for system scientists and modelers and mathematical modelers and so on. It's tools that everyone can use. We use them in Ghana with women in agriculture. Some of them can't even read or write, but we could use and develop models with them. And this is what we're going to do. Okay, we've talked about it this morning. Our world is very, very complex. And we have to deal with various issues from day to day that cannot be solved in isolation from each other. Now, how do you do that? These things are all interacting with each other. And it makes it very difficult to identify a way or identify what are the root causes of the problems. And this is a process we're going through. Issues are complex because they are multidimensional. They're always ambiguous. They are non-linear, as you've seen this morning. Nothing goes in a straight line. They are in models. There's always multiple stakeholders involved, because if you have a problem in tourism, and that includes education and agriculture and all the other departments in the government, for example, you have multiple stakeholders. And everyone has his own idea. And that makes things very complicated. Because they have different objectives. And most important is there are no quick fixes. There are no quick fixes. So what we have developed is the evolutionary learning laboratory. Evolutionary because we don't have all the knowledge at the start. We evolve the knowledge over time. Through learning, we learn from applying, implementing the things we think is going to work, and then we learn from that whether it's learning or not. And it's like in a laboratory. where we do that. So it's evolutionary learning laboratory. They aim to introduce systems thinking, complex decision making, knowledge integration skills for managers, policy makers, other decision makers. And the process includes generic skills in problem solving, teamwork and team learning. Generic skills applicable in any discipline. Evolutionary learning labs work. The purpose of this slide is really to show you that it's all to do with people. The essential and fundamental part of solving a complex problem is people, not technology. It is the experiential knowledge of people that we need to acknowledge and respect, and we need to use that for developing systemic solutions. Now, traditional thinking looks like that. You have a problem, you identify an issue, and you gather mental models, develop shared understanding of what is this problem, and then you sit around the table, have a meeting, the board, they decide what solutions we're going to use, normally quick fixes. They implement that, they reflect on it, and then they identify more problems. And they have to solve, because thinking linearly, you don't think of all the consequences and all the things beforehand, so that you can take that into account. That is traditional linear thinking. What we have developed is a way, a new approach towards solving complex problems. You see the old traditional linear thinking sitting there. But what we are doing is we go from identify the issues, then we do a step here which is called capacity building, and then together all the stakeholders and the scientists sit and they develop the models. Then they go on and they look at the patterns. You remember that iceberg I showed. And then systemic interventions and management plans. We will go through this now. I'll show you how it works. It's a new approach. A new approach to identify the issues, gather the mental models, and develop a shared understanding. You hold a workshop, for example, and lots of people come up with lots of ideas of how they will solve this problem. This particular picture was taken woman in Africa that has a problem with the quality of their lives. And they have too much labor here that they have to do, and the men sit under the trees and drink beer, and the woman has to work very hard. So they talked about, and we gathered all the mental models. Why do they think they have about a poor quality of life? And then the next step, they learn how to actually do these things. How do they develop a causal loop model? And how do they develop a Bayesian network model? And this is exactly what we are going to do the next 2.5 days. It's an integral part of every step. It's not that you just do it and it's all finished. Because as you do it, you learn more and more and more. Then the next step is to develop a systems model of the ideas that these people have. The ideas that, and the mental models of the different people. And you start putting that in a way that you can draw arrows. This one leads to this one, but what leads to that? This arrow leads to that one. This arrow leads to that one, and so it goes on. And eventually you have a model like that. You're going to learn this afternoon how to do that. And everything that goes with it. In the model, you look at, where are the reinforcing loops, where are the balancing loops, what leads to what, is there any patterns, what could be possible leverage points in the model that you have to go deeper into. You're going to do that also in these 2.5 days. Remember now, I'm not telling you what that means. I'm just saying to you, giving this lecture so that you understand what you are doing. Why you're doing what you're doing. Okay, then that will actually achieve or address the leverage points that you had identified here in this model. And that we do with Bayesian belief network modeling. And these are all the factors that will determine the goal. Is then, it now looks Greek to you, or Indian to me, but you will learn tomorrow how that all fits together. Bayesian belief network modeling. Would be okay? So I can't. So it's easy to construct for even non-modelers, people who cannot have never developed a model. It's very easy to construct, and you will see that, but because you will be all experts by the end of this course. It's an ideal as a mechanism for integrating mental models, different types and forms of knowledge and data. If you go for, say for example, system dynamic modeling, you have to have hard data, 20.4, 46.9, that sort of thing. Integrating mental models means very often you have to integrate knowledge such as it is high or the temperature is low, or when there is sufficient this, then that will happen, that sort of thing. It can link qualitatively and quantitatively factors in one model. You can have one factor is, for example, X, and X is determined is affected by two factors. The one is, say, rainfall, and you have data for rainfall, 101 millimeters, and so forth. And the other one could just be something like how people feel about it. They don't feel good about it, or it's against their religion to do that, or something like that. You can mix quantitative and qualitative models with each other. They're very representative of complex systems. That is, they link data, information, and processes. Useful to quantify uncertainties through the use of probabilities. Bayesian statistics is probabilistic statistics. It doesn't calculate something is X. there is a high probability that it will be X. That's how you have to interpret it. And complex systems, everything is uncertain. They're easily updatable. So if you learn new things, you can update the models very easily. And you determine what to do systemically, not just trial and error. If you've heard about action research, data management, people try something and then it doesn't work, then they try something else. You don't just try different things. You actually find out systemically what it is that you have to try out, which it makes it's a very big difference. And it can very rapidly perform diagnostic, sensitivity analysis, and scenario testing. The same things that you can get with system dynamic modeling. And you can do it very rapidly, and you will see how. Okay, so now we have the models there, and what you do then is you can change. See, all those boxes are elements of that system that affects the goal at the bottom, and you can change those things there. You can increase the rainfall, or you can say, what about if we have a dry year, and you can decrease the rainfall, make it low or something like that, and it will then show the size or how much it affects the goal. And those factors that affects the goal the most, those are the factors that you identify as systemic interventions. In other words, the factors with the largest effect on the probability to achieve the goal. Once you have that, those three there, and those four there, you end up with, then you have the factors. Now, how do you test that scenario testing? Just a quick example. You have a model that looks like that, and you can see that under the current situation, the values in these boxes says that the probability that you will have sustainable economic development in Haiphong in Vietnam is 47%. And then you play around with those things and you change. Very simple. You just click on the box and you change the values. And then find out that those that you can see now is marked, they shaded, were the ones that affected the goal the most. And if you change those, the probability that you will have sustainable economic development has gone up from 47 to 85%. So now we know this is where those arrows came from. These are the systemic interventions required to achieve that. In other words, those arrows over there. And you put them all together, and that becomes an integrated systemic management plan. And you can realize that some of the things would fall within the Department of Environment, some of the things would fall in the Department of Tourism, others will fall in finance, and so it goes on. but you have an integrated plan for your solving your complex problem. So that figure shows the systemic interventions that were identified using rapid sensitivity analysis. It's when you just change it by clicking with your mouse on it. Which factors have the biggest effect? The example is analyzed and discussed in much more detail in chapter 7, and the context is not important at this stage. When you get the books, you can read all of this. Okay, and then we come to the last two steps: implement and reflect. The next step for the people responsible for the different areas of management is to implement the strategies and policies that will create the biggest impact. And then they determine targets and monitoring programs and so forth to measure and observe the outcomes of the strategies and policies. And then the last thing is they reflect on the outcome of all of that. So the measurements, observations are then used to reflect, and they say, well, this thing didn't work. Why didn't it work? And they start to discuss. And they said, well, maybe it's because we forgot about one factor. We forgot about rainfall, or we forgot about some protein in the DNA structure or whatever, you know, whatever you apply this to. Okay. Then they reflect, and it leads to improved performance through co-learning. New issues may arise, and the models are then refined with new knowledge, and managing the complex issue is adapted in a systemic way. And so the cycle repeats itself over time. Sorry, just want to say. And then the cycle repeats itself over time. And that's why it's a learning model. You learn how to, over time, solve the problem. What we are going to do now is, the first thing we're going to do is, we will not do step 1, because you can do that in the practical on Friday. Step 2 you are busy with, capacity building. We are now going to learn how to develop a causal loop diagram. How do you actually get these mental models into a diagram that looks like a spaghettigram? Then we're going to interpret that and see where we can find what are the leverage points. Then we're going to take the leverage points and we will learn how to develop a Bayesian model and how to identify what is the management plan. And that's what you will be doing over the next, from now on. Any questions? I wanted to show this to you in the beginning, the bigger picture, so that you know where the things fit in that you're going to do. Any questions? Something that I might mention is you can use Bayesian modeling. You can use the sense, we actually do use that, the SensiMod. which sits in the background of eco policy. You can use sensing mode there. We have used normal sensitivity system dynamic modeling here. So there are various other techniques that you can use. In the book we mention the other techniques. But for the purposes of the course, I'm going to teach you just the CLD, causal loop modeling, and Bayesian modeling, and now you know where they fit into the bigger picture. Okay? Everyone happy? No one fell asleep yet?
Could you please tell me, sir, instead of using the mental models in the gathering information, why can't we use any other models instead of mental models, sir?
Yeah, let me put it like that. Maybe using the word mental models makes it more difficult to understand. What we basically say is, we take, and we're going to do that, we take little pieces of paper, we give to everyone, and we say, our problem is X. Then we ask questions. We have a recipe. We ask questions. We say, what is the issue? What is the actual issue you think? You know, like the women with a low quality of life. What is the real issue there? One will say money. Another one will say my social life. I have to work all the time. Another one will say health. We need good health. Another one will say we need better hospitals and clinics. And another one will say, and so on. That's the mental models of the people. So that becomes the elements of the system that we work with. Okay?
Yes.
Good. This exercise, and each one, and then on the back, oops, doesn't matter. On the back you write, the one is a symptom or a root cause, and a short explanation of what it is. Like a heart attack, is that a symptom or a root cause? And then number 2 is a degree program. It's normally a collection of courses. How could the program be changed to be a system of courses? What's your idea? And a football team is a system. What are the elements, interactions, and the purpose of the system? I have told you that already. And then the last thing you don't have to worry about. If you would like to know more, you can read other material. So you can just sit and do it right there with a pen. I find it difficult to have to bend down so far to move the slides on. I will look like a question mark. Okay, so causal loop modeling is now the step that we do when we have all the mental models of the people and you want to put it all together and put arrows in. And that's what we're going to do now. And this module, introduces you to an effective way to integrate stakeholders' diverse mental models and perspectives. You have to remember those models are very diverse. People come from different backgrounds, as I said before. And everyone has a different idea. Some people are more interested in money, others are more interested in health, and so it goes on. Then, having a causal loop diagram there, model there, it actually creates a platform for discussion and analyzing those things. What are the patterns? What are the possible leverage points in the model and so on? Okay. Okay, causal loop, yeah, I just want to mention, I have actually already done it. There are many systems thinking tools available. Archetypes, Bayesian belief networks, evolutionary learning laboratory, think to impact, sensitivity model, vital systems model, starter flow diagrams, system dynamic modeling, and many, many, many more. Sensi model, integration, and so on. We are just going to focus on causal loop and Bayesian belief network, and I told you about that. And think to impact is just a package on the internet that takes all those things together in one package. And we are not going to talk about vital systems model or anything else like that. Yeah, you remember the story? Just all the different issues we read in the menu. And I showed you one model. I just want to show you, I said all those issues are interconnected. And then I just want to show you how we developed that. You can see there the environment loop. We can use the tool of systems thinking, causal loop diagram, to develop a high-level systems model of the world issues. This model is the environmental loop. Okay, you can see the ratio between each factor and variable. And how you see it is that climate affects water, land use, deforestation, affects carbon, affects climate, affects water, affects land, but you have economic growth, affects land use. So just very quickly, because this is not, then we added to that an energy loop, where you have that same one, but climate is also energy from economic growth, energy use, that affects climate again, which will affect that whole thing, and there's that one there, and that R means it's reinforcing, it keeps on happening, but we'll get there. And then you can add the population loop, you can add the agricultural loop, you add the biofuel loop, and what you end up with is an integrated systems model of all the different factors that you read about in the newspapers, which shows you how they are actually poverty and food and land use and biofuel, carbon and climate, they all interlinked with each other, interacting with each other. So that is an integrated systems model. And that's what we want to try and do. Now that model might be a little bit too much. But all I want to say there is it provides a framework for seeing interrelationships rather than things, for seeing patterns of change rather than static snapshots. Because it tells you it will affect that. And when that affects that, then it will affect this and that. So it is not a static snapshot. Okay? Now, the basic elements of closed loop diagram is it has variables and has errors. The variables are the components, okay, of the model, and the errors are, well, the variable is a condition, state, action, or decision, which can influence and can be influenced by other conditions, states, actions, etc. It can be quantitative or it can be qualitative. So that's variables, and that's an arrow. For those who didn't know what an arrow is. Everyone recognize that? Relationship or change in the state of two variables. This thing causes that thing. Or it changed from this to that. That's what it means. For example, you have your bank balance there and interest. If you get interest, your it will affect your bank balance. It will make it higher. Correct? And then we have to put the sign at the arrow, the point of the arrow. Is it S or a plus? We use S and not the plus or minus because it's a bit confusing. Use S, it indicates a change in the same direction. If interest payment goes up, then your bank balance goes up. It's S. Same direction. Okay? Or you use an O, which indicates a change in the opposite direction. So you say, you'll see this on pages 32 and 33 of the textbook. But it means interest payment. If the interest payment goes down, then the bank balance will go down. Are you awake?
Increases.
That's a,
Bank balance will be increased.
that's an S.
Yeah.
Same direction, not an O. Okay? And that's your bank balance. What will be the sign on that top one? Interest goes up, bank balance goes up, so it's an S. Okay? But if you have expenditure, as your expenditure goes up, the bank balance goes down. So that's opposite. That's an O. Okay? Now look at those. Higher interest, how to decide on the sign. Higher interest, higher bank balance, the same. Lower interest, lower bank balance, the same. Higher expenditure, lower savings, opposite. Or lower expenditure, higher savings, opposite. That's why we don't like the use of plus or minus. Lots of people use that. It's a bit confusing. Feedback, the loops are feedback loops. Those arrows, we call them loops. They are feedback loops. As a process in which outputs from a system affects the inputs. Feedback loops arise when a sequence of interactions form a closed loop. In other words, it goes from A to B, A causes B, B causes C, and then C affects A again. In other words, that sort of thing. If you have a closed loop like that, that's a closed loop, that's a feedback in which the outputs from a system affects the inputs. Now we have different types of loops. We have a positive feedback. The R loop represents growing or declining. In other words, if it's an R, it's a reinforcing loop, which means as it goes up, if one thing goes up, say the bank balance goes up, no, the interest goes up, then the bank balance goes up further. And if the bank balance goes up, you will have more interest next time. And then your bank balance will be even higher. And that is a reinforcing loop. Understand? And that's a positive one. A balancing loop is negative feedback or counteracting. It seeks stability or return to control or aims for a specific target. And I'll show you examples of that. The example of a reinforcing loop is, well, I have mentioned to you, interest payment goes up, balance goes up. If you have more bank balance, you will have more interest, and it will go up, 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 up. And it's a positive reinforcing loop. And this is what it looks like. If you look there, the saving balance, it's a virtuous cycle. As the time goes on, because it goes up, 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 the saving balance goes up, up, up. Example of, that's a virtuous loop. There's the example of a vicious cycle. And that is, there's incidents of poor quality, then there's punitive action by management, then there's a fear of punishment, and then they hide the errors. That causes more incidents of poor quality and more punitive action, more punishment, more hiding up, and even worse quality. So that is a vicious cycle, which works the other way around. And there, the error, the line goes differently. The line goes, the quality goes down over time because it is a vicious loop. A virtuous loop, the quality goes up, like that. Okay? Now I'll show you an example of a balancing loop and a reinforcing loop. If you look at this figure here, is an example of Kappa Island. Can you see that the number of tourists goes up, then tourism revenue goes up, hotels and restaurants goes up, because there can have more hotels and restaurants. If there's more hotels and restaurants, it will attract more students, more tourists. and that is a reinforcing loop. And if that goes on and on, cat bar will just be tourists, the whole cat bar. However, there is counteracting balancing loops. There you see, if you have more hotels, then you have more waste. Then you have more pollution, which over time, that means a delay, will affect the attractiveness of Katba. Katba will become a dirty, full of paper, rubbish, and people will then, it will affect again the number of tourists. So if the attractiveness goes down, then the number of tourists will go down too. That's why, same direction. There's a bigger balancing loop, hotels and restaurants. If you have more hotels and restaurants, there's more use of underground water. And underground water is limited on the island. And there's more use of and there's less available underground water, affecting the biodiversity, affecting again the attractiveness. So there's another balancing loop sitting there. So this number of tourists, tourism revenue, hotels, restaurants, more jobs, blah, 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 has a lot of balancing loops, the B's there, which counteracts this reinforcing loop. So their management must be such that it will counteract each other and not too much development so that the whole system eventually collapses. You can do it through using logic. Growing or declining action is an R, counteracting is a B. You trace the loop by variable, and you start and end with the same verb. That is an R. If you end up with the opposite verb, it's a B. Take our example there. Oh, we don't have it here. Over there. Tracing the, you say more tourists, more revenue, more hotels, allow for more tourists. So you start and end with the same verb. Balancing loop, you have more hotels, more waste, pollution, less tourists. So it's the opposite. And that's the easiest way to differentiate between an R and a B. This is important. This little piece is why I goes through it. Tracing the loop variable by variable that we've done, and then you can count the number of O's in the loop. 0 or an even number is an R. An odd number is a B. But that's cheating. But it always works like that. If you have an uneven number or 0 in 0 or an even number, it will be an R. If there's 2 or 4 or 6 S's or O's, it's an hour. If it's an odd number, like 3, 5, it's a beat. But forget that last one because that's a cheat. Okay, there are a number of rules for drawing a CLB. I'm going to put them up here. I will ask someone to read them and explain them. Who wants to read them and explain them? Number 3, third, I don't know what's the name. You must come and stand here. You decide, you can model the whole world, but you only want to model a particular issue, the issue that you are interested in. So you just have to know where your boundaries are when you start modeling. You can't start with a cell with DNA and so forth in and end up with the world, model of the world. Yeah, start somewhere. Interesting means you just have to start somewhere. And don't start at the place in the model which is uninteresting. And that will get you going. Rule 3. Yeah. So you have a factor, say, growth. What does growth drive? And what is growth driven by? Growth is driven by, say, rainfall, temperature, and soil. And growth drives what? Production. Production, money. Okay? Okay. Very important. Any what do you call it? Element in your, you don't say increased rainfall or decreased number of animals. You just say rainfall and animals because the S and the O determines whether it's increased or decreased. You never put a verb, a noun, a verb in a block. Only nouns. Yeah. So I said, yeah. Yeah. Yeah, don't do the whole model and then put the S and the O in, because you forget how you thought about it. Do it as you go along. Yeah, it must look real. Yeah, don't fall in love with your diagram means don't fall in love with it. You don't want to change it because you like it so much. You will do many of them. Yeah, no diagram is ever finished. Thank you. No diagram is ever finished because in the learning laboratory, you learn new things, you put new elements in. And so it goes on and on. Okay. That is of the dynamic systems model of the Afghanistan conflict. Please don't do that.
Conflict of the data.
Yeah. Okay. Step 1 for a causal loop modeling, which you're going to do after we finish here. Step 1 is you gather the mental models. You think, for example, you're now in a workshop situation. You probably will form groups of, I don't know, 6 or so, and you choose a topic, and you each pretend you play the role of a stakeholder, and you put on a piece of paper what you think, what are the factors that plays a role in your topic, your issue, your complex issue that you decide on. So you get a lot, that means there's a lot of people mentioning waste. Hotels, restaurants, attractions, the island, access to market. These are the mental models which are on pieces of paper. And then those things are, you take a white paper and you have sticky paper? No. And what you try to do is to move them, the variables around, so that they're clear themes starts to come out of it. Everything to do with pollution and waste and use of underground water and so forth, that's to get all the negative things. Services, infrastructure, new construction, hotels, restaurants, number of tourists. You start to say things that are linked to each other, put it together, because it's just going to make it easier for you to draw the arrows. Then once you've done that, you take the next step where you actually draw arrows between the different boxes. And you start somewhere interesting. Remember what she said, start somewhere interesting. And you say, for example, here, okay, say there are no things. And you say, no. You say, for example, somewhere interesting is number of tourists. Let's start there. Then you say, what will number of tourists drive, and what will be driven by number of tourists? And you say, number of tourists will bring tourism revenue, and tourists, and what will drive number of tourists? Service quality and the attraction of the island, and the infrastructure that's available, then that will bring tourists. Number of tourists will also bring revenue, but it will also bring waste. The revenue will bring more hotels, which will also lead to more waste. And so you start drawing arrows between the elements. Okay? Is that understandable? Now, and decide on a topic. You can have any topic, like, for example, a happy relationship, traffic problems in Delhi, water resource protection, a research problem you have in your research or in your whatever you do, any problem you want to solve. You decide as a group what problem you want to
Six constitute a group.
Yeah, in groups of 6. And then you come up with, you ask the question, what are the issues? And then you say, the recipe is, you say, what can we do about it? And then 4 or so papers you write on what would affect the outcomes that you expect, and what needs to be in place for those things that you want to do. So you just sit and talk about the issue, ask those questions for yourself, and don't have more than about 20 papers, little stickies, on your white paper. Stick it on the white paper. The white paper, or on the desk. And then you ask yourself questions. What can be done about this? One will say, we can build new hospitals, we can do this, we can do that. And then you say, what will be the possible outcome? You will have more, better medical conditions. And then you say, but what are the barriers and drivers that will make this happen or stop it from happening? So the barriers might be financing a new hospital, not enough doctors, even if you have more hospitals, and so on. So you try to unlock your mental models. And you mustn't end up with more than about 20 of these small pieces of paper on which you have written just one word. Not what? Not only nouns, not a verb.